You ever build a sandcastle on the beach? It's a fun activity, right? But have you ever noticed what happens when the sand is too wet or too dry? Notice how it sinks more when the sand's wet. The sandcastle collapses and your feet sink deeper into the wet sand. This is because the wet sand can't hold as much weight. That's soil-bearing capacity in action. It's a crucial concept in construction and engineering. Essentially, soil-bearing capacity is the ability of the ground to support the loads applied to it. It's how much weight the ground can hold before things start sinking. Different soils, different stories. For instance, rocky ground can support a lot more weight compared to sandy soil. Solid rock holds a ton. It's incredibly stable and can support heavy structures like skyscrapers and bridges without any issues. Loose sand, not so much. It's unstable and shifts easily, making it unsuitable for supporting heavy loads. Knowing this is key before you build anything, big or small. Engineers and surveyors conduct soil tests to determine the bearing capacity of the ground. This helps them decide the type of foundation needed for a building. Think of it like this. You wouldn't park a monster truck on a thin sheet of ice, right? Same goes for buildings. You need a strong foundation to support the weight. Got to make sure the ground's tough enough. Compacting the soil and testing its stability are essential steps in ensuring that the ground can support the structure being built. This way, you avoid any potential disasters down the line. This ain't just some fancy engineer talk, it's crucial for every building project. Soil-bearing capacity dictates what gets built and how it's built. It determines the type of foundation needed and the materials used. Skyscrapers, bridges, even your house, all rely on solid ground. Without proper soil-bearing capacity, these structures wouldn't stand tall and firm. Imagine building a house on mushy ground. The soil can't support the weight, leading to sinking and shifting. Foundation cracks, walls crumble. It's a recipe for disaster. Not only is it costly to repair, but it also poses serious safety risks. Knowing the soil's strength lets us build safe and strong structures. Engineers conduct various tests to assess this. That's why engineers do tests, like driving big old probes into the ground. These tests help determine the soil's load-bearing capacity. They figure out the soil's limits, so buildings don't go for an unexpected dip. By understanding these limits, they can design foundations that ensure stability and longevity. Let's bring it down to earth, literally. Soil-bearing capacity is a crucial concept in construction and engineering. Imagine two friends, one standing on concrete, the other on a muddy field. The difference in their stability is a perfect analogy for understanding soil-bearing capacity. Who sinks? The muddy field guy, right? This happens because the soil beneath him can't support his weight effectively. Same principle applies to foundations. When constructing buildings, the type of soil determines how well the structure will stand. A heavy building on weak soil is like that friend in the mud, in for a rough ride. The foundation may crack or shift, leading to serious structural issues. Strong soil acts like that solid concrete. It provides a stable base, ensuring the building remains upright and secure. Knowing the soil type helps engineers choose the right foundation. They conduct various tests to determine the soil's properties and its bearing capacity. Sometimes they even gotta reinforce the ground to handle the load. Techniques like soil compaction, grouting, and using geotextiles are employed to improve soil strength. It's all about balance, folks. Ensuring the soil can support the weight of the structure is key to a successful and safe construction project. By understanding and improving soil-bearing capacity, engineers can build structures that stand the test of time. So, there you have it. Soil-bearing capacity, it's the unsung hero of construction. It's the difference between a building standing tall and sinking into oblivion. Next time you walk by a skyscraper, remember the ground beneath it. Chances are, some smart engineers made sure it can handle the pressure. Like, comment, and subscribe to see more content.